Afternoon, students. Once again, welcome to our experiment number 6. In this experiment, we are going to talk about hydrocarbons, aldehydes, ketones, carboxylic acids. I believe you have done this in class. You have been introduced to what are alkanes, what are alkynes, what are alkenes. Hydrocarbons generally, they are molecules which consist of carbon and hydrogen. And there are different classes of hydrocarbons. We have aliphatic, those ones are straight chain, and we have cyclic, which are circular in nature. We also have saturated and unsaturated. So, and we can be able to differentiate most of these hydrocarbons by different reactions. A few of the reactions, and due to the limitation of chemicals that we have a few of them that we want to carry out with you, but the rest of the hydrocarbons, when you come to face, we will be able to carry them out, and you see the differences. So there are different tests that we are going to do for today's experiment. Unfortunately, again, we will not do all of them, but some of the reactions you will be able to do. One of them is solubility. We want to see how hydrocarbons, are they soluble in water or insoluble? Then in other solvents such as DCM, are they soluble or insoluble? Then we will also test combustibility. You know, hydrocarbons, when you burn them, they have a lot of soot because of carbon and hydrogen ratios. So you can be able to identify a hydrocarbon by the nature of fumes that come out during combustion system. And so we will do that test also. We are also going to do I've told you combustion, I've told you DCM, I've told you water. And then after that, we'll also test now aldehydes, ketones, and acid anhydrides using some other methods which my partner, who is Eugene, will do in the next. So for the first part, we are just going to test hydrocarbons, and we are testing only 2 of them. One, we have an alkane, and the name is heptane. Heptane. Remember, heptane means it has 7 carbon atoms. Then the other one is toluene. Toluene, from the word go, as it suggests, is an aromatic. It has a benzene ring, but circular in nature. Then we have also given you one unknown. And this unknown, at the end of the experiment, you can be able to tell us which unknown A is what, so that you can be able to identify the 2. So I would like us to go to our first experiment, and that is solubility. Solubility in water. What I would like to advise you is, when we carry out this experiment, we will show you test tube reactions, and you yourself, you will be able to conclude by putting there what you are seeing. If we add solubility in water, you are supposed to tell us, is it soluble or insoluble? So we will make sure that we show you test tube reaction so well for you to make an informed conclusion. So let me start with, I will start with the knowns and finish up all. And then I will also repeat the same process for unknown. So our first unknown is heptane. So, and I would like you to change from your manual. It is written pentane. It is written pentane, but we are not using pentane. We are using heptane. Remember, all of them are alkenes, and they work in the same way. So if you look at your manuals very well, I want you to adjust from pentane to heptane. And so we don't have cyclohexene, so this one will do it when you resume face-to-face. Now, our first reaction is this. We are going to take heptane a reasonable amount, and especially I would still request that don't use too much of the solution. Use just a small amount like that one. And then we are adding in water. We are adding in water. So I want you to be observant to see whether there is any change in if the two are soluble. I hope you have recorded. Okay, I've tried to do this, but check. Okay. So I've finished my first test. I will go to toluene, which is also here, and I'll repeat the same process. So the second one is toluene, and again I'm using similar amount, and you also add similar amount of water like that. Not so much, but similarity like that. Are you able to see the difference? Okay, so you are going to write your inference in the table, what you have seen. I would also want to emphasize about density. So as you do so, remember to tell us whether is it denser than or is it less dense than water. The next thing I want us to do is for DCM now. I'm repeating the same experiment. I'll start with heptane. And then now, instead of adding water, we are going to add in DCM. Remember, DCM stands for dichloromethane. DCM stands for dichloromethane. So, I put it there. Observe whether you can see any two layers. Okay. The second experiment is now I'm using toluene. And I'll still repeat the same experiment like that and add in some few DCM. And I'll put it here for you again. Try to see. Good. So we have done for DCM. So remember that if the solutions are soluble, then we don't say one is less dense than the other. So this column, you leave it out in case you see soluble. Any compounds that are soluble means there is none that is denser than the other. So our second experiment, those ones are physical tests now. And physical are things which you can see and we don't react. So the second one we want to do, we have 4 types of reactions. One is combustion, the other one is bromine test, and the other one is potassium permanganate test and sulfuric acid test. But since we don't have bromine liquid and potassium permanganate, this you will do it when you resume face-to-face. We are only going to do a chemical test to separate this, the 2 hydrocarbons through combustion. So, and under combustion, we'll just put a few drops and then we light we see whether they can burn, and if they burn, observe the nature of soot that comes out. Hydrocarbons with higher carbon ratio to hydrogen have high soot as compared to hydrocarbons with equal number of hydrogen. The ratio of hydrogen and carbon are almost same. They have less soot. So this is what we are going to test now. And for me to do combustion, I'll actually need, I will use a crucible lid. It is easier because it's easier to see whether there is soot forming or not. So, and again, carefully, this is an experiment that is dangerous in the lab. So care must be taken when you are carrying it out, because remember, hydrocarbons are flammable. And once they are flammable, it means that we need to carry them out near the window so that most of the fumes can go out, so that they don't accumulate in the lab. So for this reason, I'll take my combustion next to the window and I'll perform this experiment for you to see the soot. So I will start with heptane to do the combustion. I'll put a small amount and I'll just light. Observe the nature of the flame, observe the soot. Okay, you're able to see my petri dish. It's almost looking clear with less soot. Now let's see the toluene. I'll just also put very few drops, 1 or 2 like that, and then I'll also light. Observe the difference. Good. So you are able to see the two flames. You can be able to explain what happened. Now we have finished with the knowns. We have done combustion, we have done solubility in water, solubility in DCM, and now we want to see the unknown. From the unknown, you will tell us which one of the two can identify itself with unknown. I will start with the first reaction, which is solubility in water again. So I'll pick my unknown like this. And I told you that the unknown is one of the two reagents that we have given you. So we'll put in water like that, and we'll leave it to settle. Okay, then I will put it again, unknown, a little bit amount, and I'll put it with DCM together, like that. I'll put DCM here, like that, and I'll put it here. Observe the difference. Okay. Then the next experiment I'm going to do is combustion for the same. I'll take my unknown and go back to the other side so that we also burn. You can be able to identify it. I'm going to pick a small of our unknown like that, and then we burn it and try to relate. Oh, sorry, it's not burning yet. I'll add more, just a little bit. Okay. Observe the soot. It relates to one of those hydrocarbons, if I'm not wrong. Good. There we go. So you can even see how the okay. Now we have done a few tests, as you can see, but several of these tests, when you come back, you'll see them, the ones we have not done, to identify hydrocarbons. And so I will want to invite my colleague Eugene to carry out the second part of this experiment, which is to identify the aldehydes, ketones, and acid anhydrides. Thank you.
Hi everyone, so my name is Eugene. Now I'm going to take you through the second part of this practical, where we are going to identify aldehyde, ketones, and carboxylic acids that we are going to use today. And then we have our two unknowns, which is part of this. So we have aldehydes, acetone. This is formaldehyde, acetic acid, and ethyl acetate. So we have a total of 4 tests that we are going to do today: solubility, acidity, iodoform test, and bicarbonate test. So I'll start with the first one, that is solubility. So I'll take a few drops of formaldehyde, add water, distilled water, like that. Now observe from there. That's fine. I'll go to the second one. This is acetone, and then add distilled water. Check and record the observation. Our third one is acetic acid, like that. Then view. Okay, and then our last one, last known is ethyl acetate. Just add some few drops, and then we add water. Now we should view. See if there is any difference from the other. Now we are going to do our unknowns and see if you can identify them from the 4. Our first unknown is unknown B. Add a few drops. Then you add distilled water. See if there is any observable changes. Okay, then we go to our second unknown, unknown C. Add a few drops, then distilled water. See if there is any observable changes, and see if you are able to identify our unknown from our knowns. If that is not possible, you can't identify using their solubility, we go to the second test, which is acidity. Now I'm going to do acidity of the knowns. We have our pH paper and the wheel that has from pH 0 to 14 the color change. So I'll need you to observe the color changes. Look at this. that is formaldehyde. Look where it falls and record. Okay. Our second one is acetone. This is the wheel. See where it falls. Our third one is acetic acid. This is the wheel. See where it falls on record. Our fourth one is ethyl acetate. On the wheel. See where it falls. Okay. Now I'm going to do my unknowns. The same test, the acidity, pH test. That is unknown B. Look at that, see where it falls, record. And then unknown C. Look at that and see where it falls. Okay, so maybe acidity have made you identify maybe one or both of our unknowns. If not, we'll go to the other part, which is iodoform test, to see if we can still be able to identify our unknowns. So I'll start with formaldehyde. Then, as the procedure says, we add 1 ml of water. So I'll add. This is qualitative, so we don't have to be so precise, to be so accurate. And then we add some drops of sodium hydroxide, which is here. And then finally followed by few drops of iodine. So when you add iodine, this is what we get. That is formaldehyde. So the second bit is acetone. Then a few mils of water, followed by 10% sodium hydroxide, and finally the other solution of potassium hydroxide and iodine. So this is what we will form with acetone when we do iodoform test. So from the literature you should be able to know what we use our iodoform test for, what type of analysis, for what identification. So I'll go to acetic acid, repeat the same procedure. Sodium hydroxide, then that is acetic acid. Okay. Then the fourth one is ethyl acetate. Then a few drops of water, sodium hydroxide, and the solution of Ki and iodine. So this is what we get with ethyl acetate. So I'll go straight to our unknowns. This is unknown B. Few drops. Distilled water. Sodium hydroxide 10%, and our iodine solution. That is unknown B. Okay? And finally, unknown C. Some water, like that. Sodium hydroxide. That is our unknown C. Okay, so from that, maybe you have been able to do some identification with the iodoform test, but we just want to maybe do further tests so that you can confirm that maybe whatever unknown you have in mind is actually correct. So I'll do the last part of this practical, which is bicarbonate test, for our last identification. So I'll start with formaldehyde. Add a few drops like that, and then 5% of our sodium bicarbonate. See if there is any observable changes. That is formaldehyde. Okay. Next part is acetone. 5%. Look at that. That is acetone. Then we go to acetic acid, and then add the 5%. Take note of what is happening. Okay. Then we go to our ethyl acetate. Add. See if there is any observable changes. So I'll go to our last part, our unknown B. Add. That is your unknown B with sodium bicarbonate. And finally, unknown C. Okay, so that was our last test. I'll finish it from there. So if you have any question, then you can ask. Thank you.